So once we have our type of test determined and we know our alpha value and all those things, we can now go ahead and make our decision, do our step 6. So let's say, hypothetically speaking, that we have a situation where our alternative hypothesis has the less than symbol in it here, which makes it a left-tailed test. So that would leave us with our diagram right here. And let's say that alpha was equal to 0.05. So that means our area in our critical region or our rejection region would be equal to 0.05. Well, now in order to make a decision using the critical value method, we have to go and find what's known as the critical value, which is the z-score that corresponds to this location right here. So if we were doing a test of means, we would go into our standardized z-score table and we would look up what z-score has an area of 0.05 to the left of it. And if I remember correctly, that's a negative 1.96. So this right here is known as our critical value. So the critical value comes from the size of your area, which comes from your alpha value. Now, once we have our critical value found, the next thing that we're going to do is we are going to need to determine where does our test statistic from step 4 fall with respect to our critical value. So the area of the critical region or the rejection region is going to come from our alpha values. This other area, think of this as the non-rejection region. So what we do is we take our test statistic. So let's say that our test statistic from step 4 was negative 1.37. And what we do is we take this value and we compare it to our critical value. So a test statistic of negative 1.37 would land somewhere over here. And what we do then is we look at, did it fall in the rejection region or did it fall in the non-rejection region? So in this case, it fell in the non-rejection region, which means that we would not be able to reject our null hypothesis. Now, let's say our test statistic was negative 2.137. Well, in that case, it would land down here somewhere. And since that is now in our critical region or our rejection region, then we would have evidence that would allow us to reject the null hypothesis. So when you're doing the critical value method, you have to use the standardized table to find your critical value and then compare your test statistic to the critical value, which will then allow you to make the decision. Okay, now on the other hand, if we use what's known as the p-value method, we are not going to be finding critical values. So let's say we are still working with an alternative hypothesis that has a less than symbol in it, which means we're still going to have a left-tailed test. But now what we're going to do instead is we are going to find what's known as the p-value. And this is still going to correspond to an area on our diagram here, but it's going to be an area that represents a different value. So what we would do first of all is we would graph or plot, I guess, our test statistic, and we would find where that lands. So let's say our test statistic was equal to negative 1.3. What we do at that point is then we go and we find the area associated with our test statistics. So you would go to your standardized table, look up, we're going to assume we're still doing a z-score again, look up a z-score of the negative 1.3, and that's going to be the area that we're going to put on our diagram. So the area associated to the left with a negative 1.03 was 0.0698. So that's going to be considered our p-value. So 0.0698. That represents our area in our diagram, and that's determined by your test statistic. Now, once we have our p-value found, what we do is we compare that to our significance level, our alpha level, and that's going to allow us to make a decision. So if our p-value is less than our alpha level, we get to reject the null. If our p-value is not less than alpha, we fail to reject the null hypothesis. Okay, so with the critical value method, we compare the critical value to the test statistic. With the p-value method, we compare the p-value to the alpha. So both methods have about the same amount of work involved in them, but the p-value method is actually probably more commonly used than what the critical value method is. Once we have decided which method to use and then we make a decision, then we can go ahead and finish this off by writing our conclusion in non-technical terms. So if we are allowed to reject the null hypothesis, typically we would say that there is sufficient evidence at the, and then you would put in whatever your alpha level was. So like if we did the 0.05, so there's sufficient evidence at the 0.05 significance level to reject the null hypothesis and support the claim, and then we would want to insert whatever our claim is. So whatever we were trying to show is what we would want to describe in there. That is if we are allowed to reject. So if we can reject the null, which is saying, you know what, the null was not true, so our alternative that we are supporting down here must be true. Now, let's say our test does not allow us to reject the null hypothesis. Then we would usually use the phrasing along the lines that there is not sufficient evidence at the, and then you would put in whatever number you have here for your alpha, to reject the null hypothesis and support the claim. So this one we're saying we don't have evidence to reject this and support what we thought was happening. Now, one thing that we do not do, if we are in this fail to reject, we do not say that we accept the null hypothesis, because we don't have proof to prove that it was true. Kind of like with the four-legged dog example before. We don't necessarily are able to prove that it's true. So we don't say that we accept it or that it's true. We just say that there was not evidence to reject it. So those are kind of the basics of hypothesis testing. Once you get into actually doing the test, it will become a little bit more fluid and a lot easier with some practice. So our general steps, though, is that we need to determine the type of test we have. We need to state the null and the alternative hypothesis. We need to determine our significance level, and then compute the test statistic. And remember, this comes from your sample. Once we have our test statistic, then we get to choose if we want to do the critical value method or the p-value method. And then we get to make a decision, and finally we get to write the conclusion in non-technical terms.